The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar entitled Artificial Intelligence Impact on CX and FM for Educational Facilities. My name is Billy Zadig, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional Continuing Education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order that they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. At this time, it's my pleasure to turn this over to Robert Knadler, our speaker for today. Bob, take it away.
Thank you, Billy. Again, Bob Knadler. I'm with the Energy Management Association, currently on the board. And I think everybody would agree that artificial intelligence is one of the hottest topics around. In fact, in regards to that, there was a recent worldwide poll that showed that 64% believe that artificial intelligence is the most relevant technology of the future. And that's an increase because that same poll a year ago reflected 41%, that 41% thought that AI was the most relevant technology. That's an increase of 23% in 1 year. So obviously, a lot of people are interested, a lot of people are out there. In many ways, maybe they're experiencing it. A lot of publicity comes, as you know, from what is shown in Chat GPT and some of the other artificial where they're creating different pictures, they're writing different reports, etc. But what I want to do today, I want to talk a little bit about facility management components, some of the challenges with institutional facilities. We're going to talk briefly about AI, artificial intelligence, its development, kind of where we are today, and then bring that into how it's had an effect and continues to have an evolving effect in facility design, construction, and operations. And then we'll get specifically into some of those areas where it has had an ongoing influence and continues to have an increasing participation and influence in those areas. And then we'll wrap up a little bit with some of the challenges going forward, and then the need for what we call upskilling in terms of some of the training that needs to take place. So talking a little bit about facility management, I really see three main areas: administrative, occupant tenant support. We'll talk about building services. So you can kind of see here from these tables that I've, or these lists that I've created on this slide, that again, facility managers are involved with strategic planning. Again, they have their own staffs that they have to recruit and train. They get involved in budgeting, not only in operational, but a lot of times in capital. Obviously, infrastructure and utilities, contracts with various vendors. And then oftentimes they're responsible for what I call technology integration, the ability within their facilities to integrate technology, not only for their own staffs, but for other users, occupants, and even tenants. As far as tenant support, we talk about it here on the right, that stakeholder communication, the ability to share with them what's going on in terms of the facilities, any programs that are being developed, any interruptions, any construction. They may have to do training in how building systems are operated, health and safety compliance. They have to respond to any complaints, and then emergency preparedness. The third leg, as I call it, is building services, and you can kind of see it here in these two lists. Again, the ability to monitor what I call the key asset performance metrics, monitoring IEQ. Again, they get involved in planning and space management, response to work orders, as I mentioned, preventative maintenance. Oftentimes, They're heavily involved in security and access control. And then from a construction standpoint, often they need to manage or at least oversee various renovations, refurbishments, and even some new construction. Periodically, their staffs or their consultants may be brought in for various facility condition assessments and or audits. So what are some of the challenges with this? I mean, you've got an individual or a staff that have all these different responsibilities. Well, number one, the size, the age, and the variety of various building types and systems. You know, you could have a college or university campus that has anything from class buildings and administrative buildings to student centers, residence halls, data centers, lab, both research and teaching laboratory facilities. So you've got quite a variety there. They may be saddled with multiple sites, maybe satellite campuses and or various physical plants. Ongoing capital program. The fact that almost every, this applies to school boards as well, but again, I don't know too many out there that don't have an ongoing program, if not for new construction, at least for major renovations and maybe even repurposing some of their facilities. The fact that schedules change based upon various semesters and the occupancies, limited staff. They could have a very tight budget. Their staff may have limited expertise. We're going to talk a little bit about that at the end. The integration oftentimes that facility managers have with not only the responsibility of maintaining facilities, but energy, environmental, even sustainability goals, facility resiliency, the need to make sure that everything stays up and online, operational continuity, and then finally dealing with various occupants and tenants, you know, whether it's teachers, whether it's other staff, students, could be even tenants that are providing food service in some of the facilities. So we want to talk briefly, I talked about definitions of AI. So I list here artificial intelligence, machine learning, and deep learning. And you can kind of see from the definitions that, again, artificial intelligence at the onset there, it's basically creating smart, intelligent machines. And as you see the graphic on the right, that's sort of the outer box, okay? A subset of that is what they call machine learning. It's a subset that uses algorithms that's really trained on data to produce adaptable models. And initially, a lot of this training was done, again, by humans. We're going to talk a little bit about the fact that some of this training now is done even within themselves. And then you've got the deep learning, and it's a subset of machine learning. And you can kind of see the inner box there with all those different acronyms. It's not important that you know the acronyms. Say LSTM is long short-term memory, MLP is multi-layer perception, etc. But the idea is that this is sort of what we're talking about that is starting to evolve even further. And then this is what is utilized in various applications. And we're going to specifically talk in a couple slides here about its use in what we call construction 4.0, design, construction, and operations of facilities. Now, before that, I want to talk again briefly about the development of AI. The first, basically what's happened is that it's generally recognized, a lot of people have described the development is what they call waves, okay? And it continues to evolve. And for those that think back about the personal computer and the chips and the development of PCs, and there was always this unwritten rule that every 18 months, the speed of these computers would almost double. It was just that kind of development in the processing speed and the processing chips. Well, the same thing's happening here, is that these waves of AI, the first wave was what they called the crafted knowledge, rule-based AI systems with algorithms and the software based upon human experts' knowledge, as you can see here. The second wave was what they called statistical learning. And these models or machines were really trained on really a vast amount of data. Third wave was contextual adaptation, and they were basically trained and they could understand and start to respond to the context of a situation. Now, this really required extensive research and innovation as it went forward. Now we're really, I think a lot of people believe we're in the fourth wave and with future waves coming. And as I say here in my final bullet, generative AI or Gen AI with advancement to understand and perceive the world and again, and this is what some people fear, some people relish it, the fact that they could surpass human capabilities, providing us with remarkable insights and transforming the way that we live and interact with technology. And this is really sought to lead to a rise of autonomy. You know, this is what we're talking about, the ability of self-driving cars and some of the other aspects in other areas outside of facilities. So I showed you 2 slides back when we talked about AI, machine learning, and the deep learning. We've got applications here, and this is what we're talking about in building and construction industry 4.0. Well, what is that? Well, again, not going very deep, but influenced by what they call the principles of industry 4.0. Construction 4.0 really encompasses building information modeling, BIM, which most people are familiar with if you're in the design and construction field, and what they call diverse semantic and geometric data. And as you can see by the 7 bubbles that are around the center, you know, of construction 4.0, all the various aspects and you know what I call applications of AI within all these different diverse fields. Although they're all related to design, construction, and operations. And really, the one that we're talking about is the one in the middle at the top, smart building operations, and really the health, in terms of the health of the building. And it deals with facilities, facility operations, and management as we go from there. Now, really, this is nothing new, in as much as AI has been evolving in BMS platforms for a while. And as I say here at the top, various companies, and these include people like Siemens, Honeywell, Johnson Controls, they've already been integrating AI algorithms into their cloud-based building management systems and those platforms. And again, the intent to make those platforms actionable and help with predictive decisions. You know, what's the ultimate goal? Well, the ultimate goal is, number one, to reduce operational costs and to achieve, as I say here, energy and occupant experience goals based on historical and real-time data. Again, the fact that AI has the capability of basically taking in and analyzing massive amounts of data. Beyond HVAC, AI algorithms have been what I call purpose-built for other systems. And these include anything from smart lighting, power delivery, water management, fire safety, and even various systems and data security. The idea is to provide step-by-step instructions for really calculating the optimal settings and for, again, machine learning systems to identify patterns in a building's life cycle. The ability to take in massive amounts of data and through algorithms do the analysis is really at the heart of artificial intelligence. Now, some of these BMS platform providers have their own teams, AI teams that help develop their algorithms, and others are partnering with AI consulting and development services like Intel, IBM, Accenture, and Infosys. So I kind of like this graphic, and you kind of see I give credit to Bosch, and it's basically the cycle in facilities management. And when you take a look, you've got all your building systems up kind of a little right of center at the top. And basically, as it comes around, the information is generated, and it's generated by various sensors, various IoT, Internet of Things devices, and all that comes into databases. And then there's what they call semantic enrichment of information. So, and then what does that mean? Well, again, you need systems that can manage and store large amounts of data. And it can come in what they call time series databases, what they call TSDB. And those are used to both monitor the data storage, but you also need a way to model or describe these data streams. So you have all these data streams, so you've got to have some sort of an overlay, a semantic way to enrich it or define it. You know, which sensor is generated, okay? Which sensor generated the data? Which metric of which piece of equipment or system the system is monitoring? Which unit of measurement is being used? What's the relationship between this sensor or measurement and other sensors in the system? So that's that enrichment that's done with this massive amount of data. And then again, the processing analysis through what they call artificial intelligence, and then it feeds back, controlled by technicians and facility managers. So now getting into some of the topics I want to talk about, specifically with respect to, again, commissioning, energy, and facility management. It's already being employed through a lot of these areas, okay? And some of the bullets that you see here in these two lists, these two columns, talk about various areas, and we're going to talk about them briefly as we go through where AI is being employed. We're going to look at each of them. So let's talk a little bit about facility commissioning. Again, artificial intelligence, as I mentioned a second ago, we were talking about that construction 4.0. It's already being employed all the way through the early planning stages, design, and even into construction, but also in developing virtual models of facilities and simulating their performance. And it really helps to give quality control and to assist commissioning providers in their role for project oversight and system verification. So, I mean, controls contractor oversight. Well, one of the things that during construction towards the end is a real challenge oftentimes for commissioning providers is, you know, what's the status of the controls? You know, how much has been installed? What's the status of the communication network? What's the status of the number of sensors or points that have been mapped? And being able to track that progress is really important. And there are systems out there that help in that tracking that can be accessed remotely to let a commissioning agent or commissioning provider know where it is, and maybe even what the pre-testing that's been done, okay, with respect to any device communications, maybe any third-party integration with other systems in the building or facility, and even point mapping or graphic, so that they can get a gauge on the progress of where the controls are. You know, next, automated functional testing. Well, one of the things using AI is, again, to analyze and command the points that are really based upon some sort of predefined testing scripts. The idea that you can actually set up these scripts and you can run tests, for example, on massive numbers of terminal units like VAV boxes or whatever, and let those run and trend them to see how they're operating without having to go in the field and measure every single one of them. collection of data for certifications. Again, there are certain certifications like WELL where certain amounts of data have to be tracked in terms of space performance, temperature, humidity, indoor air quality, and AI can help in collecting that data and basically helping in terms of developing the reports for certification. Again, fault detection and diagnostics, particularly in advanced monitoring-based commissioning systems. Again, FDD, or again, facility detection or fault detection and diagnostics, can be used with automated testing. Okay, it can help to identify issues within system operation, and it can provide specific diagnostics. It's really critical in the ongoing operation. Key performance indicators. Again, the ability to assemble key performance indicators for metrics like occupant comfort, energy use, building occupancy, IAQ, that's also equally important and is often one of the keys that commissioning providers and others are looking for towards the end of a project. And as well as facility managers as in their ongoing commissioning aspect as they basically track the health and the performance of the building in future years. Energy analysis and prediction. Again, one of the things that can be done is you can import data from a building energy model, and you can use that to compare to the actual energy use, against the model, the actual energy use, the model, and even maybe some code baseline that you have. And then finally, if you had to, you could use linear regression, again, based upon occupancy, based upon weather, based on other aspects to make adjustments to what the model had versus what the actual data is showing, to make that adjustment so it can be a fair comparison. Again, linear regression analysis is often used. And then finally, ongoing commissioning and sharing historic data for future assessments of the building or facilities and future audits. It's all very important going forward. So another aspect is enhanced operational efficiency through operation, or I should say through automation. AI algorithms use information from historic data. And then equally that, optimized energy management for both energy and cost reduction. So one of the things about AI-powered building management systems, or BMS, it really goes beyond basic scheduling and simple automation. Again, using those advanced data analytics and those machine learning algorithms, it can make intelligent decisions and in real time to optimize energy consumption. For example, the system can consider factors such as occupancy patterns, weather forecasts, historical energy usage data, and then to dynamically adjust HVAC systems, lighting, and other equipment. So, I mean, if you took a typical classroom building, AI can detect patterns in occupancy data. It can adjust temperature and lighting levels accordingly. And during periods of low occupancy, it could reduce the energy usage in unoccupied areas, basically ensuring that energy efficiency without sacrificing comfort. One of the things that they found, we talk about dynamically adjusting systems, but the ability of AI systems to predict zone temperatures based upon historical data, they've been able to predict zone temperatures with about a 95% accuracy to date. Also using AI-based management systems, they can improve energy efficiency by about 30% and reduce carbon footprint by as much as about 40%. So the next aspect I want to talk about briefly is predictive maintenance and fault detection. We talked a little bit about that a couple slides ago, fault detection and diagnostics. But again, turning data into predictive alerts. Really through real-time analysis of all this data coming in, this sensor data, AI can identify anomalies and patterns indicative of, let's say, potential equipment failures. It can detect maybe subtle deviations from normal operation. Again, how you set up your algorithms. And that's going to allow technicians to intervene before major issues occur. You know, by scheduling maintenance activities based on predictive insights, the building management system minimizes downtime, helps to reduce repair costs, and improves the overall reliability of critical building systems. And as I say here in my final bullet, some studies have shown that AI-enhanced predictive maintenance can lead to a 70% reduction in breakdowns and between 10 and 20% increase in equipment uptime. Another aspect is what I call space optimization or planning. Again, the ability to optimize the use of space for productivity and efficiency, okay? And several firms have been able to use this. I show some of the bullets here from automated housekeeping management, real-time utilization detection. There's ways that they can monitor what the occupancy is at all times, even automated people counting. And the idea is that now we're really getting into generative AI. So generative AI can provide insights into the optimal spatialization, adapting really to the user's behavior and needs, ensuring that workspaces are not just efficient, but that they're also suited to evolving work patterns. You know, not only analyzing data from occupancy sensors, they can adapt the building systems to match individual preferences, improving occupant comfort experience. You know, take for instance, AI can learn from historical data and adjust temperatures and lighting levels based upon occupants' behavior. If an occupant preferred cooler workspaces in the morning or dimmed lighting during certain hours, the BMS could be very proactive and could accommodate those preferences. It can also help identify underutilized areas. So that's part of what's important and gives you additional capabilities from the standpoint of facility managers. So minimizing human error, and then again, data-driven decision-making with AI analytics. So one of the ways it minimizes human error is automated monitoring and control systems. AI continuously monitors and adjusts building systems operations in real time and to adjust performance. So automating these systems and automating these adjustments helps AI to reduce the potential for human oversight or errors that could lead to inefficiencies or maybe even system failures. So let's take, for instance, let's say AI could automatically lower heating in unoccupied spaces, something that could be overlooked by human operators. So, and then as far as data-driven decision-making, AI really helps to set new standards in decision-making. It really helps to demonstrate or showcase an unparalleled ability to rapidly digest and analyze various amounts of data. Again, that ability to take in data is so critical, the ability to take in massive amounts and analyze it. Now, another aspect is what I'd call data democratization or accessibility. Again, the ability for stakeholders to become engaged, basically opening up the environment to be more inclusive in decision making and to help develop and distribute those key performance indicators for transparency. Okay, it's really key, as we talked about at the very start, for facility managers to engage the occupants of the building and what they call their stakeholders, okay, and share with them those performance metrics and help to promote what I would call transparency or collaboration, okay, between the occupants of the building, the maintenance staff, maybe even administrators. And this is going to help with the facility's image and reputation. Equally important would be indoor air quality, the ability to monitor IAQ for the occupant health and safety, as well as security devices and access control. So predictive building maintenance and management for what I would call seamless operation. So again, one of the things that AI can do, traditional maintenance schedules, oftentimes they may be too frequent, or they may be not frequent enough, too infrequent, that would cause, maybe unexpected equipment breakdowns. So the idea here is through what we call predictive alerts and maybe automated adjustments, AI can help to ensure that facility management can understand and maintain uninterrupted operations. It can help to reduce downtime and prevent potential issues before they become costly problems. So scheduling, as far as resource and staff and inventory management, is really key as well. And then as far as customized solutions, again, generative AI offers the ability to develop and adapt various solutions to evolve in real time. Okay, this dynamic, it's kind of a dynamic learning and adaptation process. And it's really informed by what I call continuous user interaction or environmental feedback. And it allows, again, AI to offer tailored recommendations, okay? Another thing is addressing alarm overload with AI. Again, intelligently filtering and prioritizing. One of the things that facility managers often have, particularly in large facilities, is that challenge with a number of alerts or alarms. And one of the things AI can do is that they can intelligently filter and prioritize those alarms, ensuring that only the most applicable, the most pertinent ones reach facility managers and prioritize which ones should be tackled first. And this helps to mitigate what they call alarm fatigue. It also helps ultimately in terms of safety and operational efficiency in terms of using your staff. So on the other side of, we talk about maybe some of the benefits of artificial intelligence, but what are some of the challenges? And there are a number of challenges that go along with it. And one is what I would call the potential security vulnerabilities. AI collects and analyzes a massive amount of data, from all the various sensors and IoT. And this data can be very valuable, as are the assets, and it makes it very attractive for malicious actors or hackers to attack the systems. whether it's by ransomware or whatever the case may be. Sophisticated adversaries can employ AI to enhance their ability to attack facility systems. So you have adversaries that can use AI to attack your system. And on the other hand, AI can add another layer of security. I mean, you've got two sides to this coin here, and there has to strike a balance. So you have to be ultimately aware of the cybersecurity issues associated with AI. And just like I said, it's got the capability of managing and prioritizing alarms and alerts. On the other hand, depending on how the algorithms are set up, if too much reliance is put on AI, it could start to result in a number of false positives, depending on, again, how you've set up the parameters of your algorithms. And so that could also lead to alert fatigue among security officials. So there has to be a balance here in terms of the benefits versus what the challenges are with respect to security. Another aspect that's equally important, because we keep talking about automation, we talk about this artificial intelligence, is what I would call balancing automation with human contact or the human touch. Some aspects of facility management will always require human intervention. There has to be a level of human touch. So there has to be a balance to ensure that technology serves as a tool to assist the FM staff, and it's not totally relied upon. It's not going to be a substitute. Interoperability concerns. Again, you need to, for those that are interested in engaging systems with AI and to basically integrate them within your current BMS platform or your energy information system, there needs to be open standards and platforms to ensure that integration, particularly if there's diverse systems, and to ensure that seamless communication. That's a challenge as well as you go forward. Another is data overload. And this gets back to, again, the fact that between the Internet of Things devices, the IoT, and sophisticated BAS systems, they generate a vast amount of data, going back to that graphic I showed you earlier. And you have these time series databases that are being generated, whereas I talked about the semantic overload, or I should say overlayer to basically define what all these databases are. The FM staff could easily be overwhelmed without effective algorithms to process, derive insights from all that data. I mean, it's really important. Another one is cost implications. The initial investment required to integrate the IoT and AI can be very significant. While there could be very long-term benefits that will justify the cost, but again, administrators and facility managers must be strategic in ensuring that their investment aligns with their needs and helps to deliver a return on that investment. And then finally, what I want to talk about a little bit is AI's appetite for energy. And some of you may already be aware of this. By 2030, data centers are expected to reach 35 gigawatts of power consumption annually. And that's up from about 17 gigawatts last year. So that's more than double. That's according to a study by McKinsey. In addition, a recent Cohen research report estimated that AI data centers could require more than 5 times the power of traditional facilities. And this is why you see the stories out there about, is the US running out of electricity? Because again, the massive amount of energy required for AI. My third bullet talks about the fact that there's forecasts out there that predict that data centers could drop to 16% of the US electrical supply and 21% of the world's electricity supply by the year 2030. When you think of all the various uses of electricity, that's a significant number. So what are one of the things that I think is important? We talked briefly at the beginning. Where does this leave us? Well, AI requires, as I say here, a proactive approach to upskilling for FM professionals, you know, in terms of training and upping your skill levels. Number one, data literacy, the ability to understand and interpret all the data generated, you know, by these AI systems. And even as I spoke a second ago about the various algorithms and the fact that you can utilize them to help to collate and analyze, you know, that data, you still have a human component that has to be able to oversee this going forward. AI system management, the proficiency of managing and overseeing these systems. Okay, that's also a requirement going forward. Cybersecurity awareness. The integration of AI requires an increased reliance on digital systems. Well, that goes without saying, and we just talked about the two sides of the coin with respect to that. That on the one hand, there are AI systems that help in terms of more protective cybersecurity, but on the other hand, AI is increasingly being used by malicious actors and by various hackers to try to enter others' AI systems. Collaboration with AI. You need to foster with your staff a focus on collaboration between human professionals and AI systems. Again, that human touch, you cannot lose that. AI is important. It can bring a lot of benefits, but at the same time, there still needs to be that human oversight. And then continuous learning. The fact, as I said earlier, that this is a rapidly evolving area, okay? Given the rapid advancements of AI, okay, facility managers need to commit to a program of continuous learning, staying informed about emerging technologies and industry's best practices. So I'll close by saying that in terms of facility management, the future of facility management, in my eyes, relies on an integrated collaboration between what I call the skills and expertise of innovative humans and artificial intelligence to ensure energy efficient, safe, and healthy facilities for both occupants and staff. With that, concludes my formal presentation. There's my email for those that may want to contact me. And I guess I would go back and ask Billy or Karen if there's any questions that have been posed. Hello?
This is David McCabe from APA. I was wondering if Billy's just having a little technical difficulty. So while if we're waiting for Billy to come back, I can read There looks like there are a couple of some questions here. I just
Sure.
want to know there are a couple questions, general questions about the recording of the presentation being made available. Yes, that will be available tomorrow. It'll be on our YouTube page there as well. So let me bring up when I just had the questions and then they disappeared
Okay.
on my screen here. Hang on, I apologize.
That's fine.
If I can get this to expand, it was. So let me see the other ones. Is there any university that you know of that is AI right now, or any institution?
There are a couple of universities that are employing SkySpark, which I consider SkySpark in terms of a advanced BMS system with very advanced fault detection and diagnostics. It's by SkyFoundry. There are a couple of universities that I know of. One is the University of Central Florida. There's a couple of others that are, I believe, the University of Georgia, a couple others that are starting to employ it. They're basically, again, it's a significant investment. So a lot of times what these colleges or universities do, they'll pick a couple of buildings. They start out with the installation of so many sensors, and then they basically grow that as their budget goes forward. The other aspect of that is you need somebody that's got the training to really oversee and control, not only control and monitor that system, but have the capability of adjusting the algorithms in there. For example, if you've got certain sensors that you want between certain parameters, the ability of how can you adjust those parameters when you need to. So there are a couple of what I would call major universities that are out there that have it. And I'm sure there's others. If you talk with people out there, and if you talk with some of the control companies, if you talk with, like I say, SkyFoundry, you could probably get a better list.
Okay, there's a good question here. It says, when calculating the possible energy savings, are you taking into account the energy that's required to run AI?
That's that's an excellent question. I mean, I would, depending again on how your system is configured, I would definitely include that. I think that that's an important component, is how much energy is being consumed by your AI system or systems. And it's like when I teach a course on energy management and I talk about EUI, we want to look at all the energy sources coming in, and we want to include the cost of all of them.
Okay, great. I'm looking through to see if see the other questions.
I'm checking my microphone.
Oh,
now.
are you there? Yes, you're. I can hear you, Billy.
Thank you. Yes, I was having a technical difficulty.
No worries. Do you want me to turn it over back to you?
Go ahead. You're doing a great job.
Oh, thanks. There's only a couple more questions here. It said, what kind of training is needed by a CX provider for AI integration?
Well, I think that it's a typical trade. Well, my belief is that typical CX providers should have a strong background or knowledge of basic building automation or building management systems. I think that additional training in terms of these more sophisticated systems like SkySpark. I know a couple of CX firms that have that kind of background, that have individuals that have that. It's basically a strong knowledge in being able to assimilate the data, take the trends, take the data that's being analyzed and fed, and being able to evaluate it. And then I know of different commissioning providers that have such a strong background that they can actually go in and they can program or install what I talked about, these various test scripts to help run on these various systems to do some of that automated functional testing. So it takes a level of experience in those types of BAS, BMS, and similar types of systems, what I call energy management systems.
Okay. And looking through here, somebody, it was really, it wasn't a question, it was a comment. It was that institution was saying they're expanding the data sets that they're entering into SkySpark. Then they're working with their energy management group on this. So I'm guessing that was in response to the question about taking into account the energy that's needed.
Right.
Okay, looking through here. Again, I see a couple more questions about where the recordings be made available. Yes, the recordings and the slides will be made available. I think I'm going to, let me do this by when there's received the most recent question here, time-wise. Well, I'm not quite sure what they were mentioning. You might know, but this question, it says, does it mean that we need a digital twin to work with that or not? If not, maybe the person who submitted that, if they could give a little bit more of a clarifying clarification to that question.
Well, actually, I understand where he's coming from, which is creating a model. A digital twin is basically a virtual model of the building and its systems. And yes, that is part of how they, you don't have to, but that's really a part of how they can run and basically pre-test some of these test scripts is through a digital twin, okay? You know, we're talking about facilities here, but there's a lot of industries where a digital twin, in manufacturing, in electrical utilities, where a digital twin is being created. For example, electrical utilities use them, where they use that virtual model and then they run various scenarios on it. What ifs, okay, there was a interruption to service. There was some sort of catastrophic interruption in some part of the grid. You know, how would the system react to that? So the use of a digital twin, even at a facility level, if the money's there, you can create it. Yeah, there's an advantage to that.
Okay, thanks. Thank you for answering that.
Go
through here.
I have one for you, Bob. Is there any university that you know of that is currently using AI?
Well, like I said, the ones, if we're talking about AI in facilities, which I'm sure that's what they're asking, University of Central Florida, I know, has got SkySpark, has got a fairly extensive installation of SkySpark. UCF, which is in Orlando.
Do you know, I'm trying to run through some of these as well with David. What kind of training is needed by CX provider for AI integration?
Well, I talked about a little bit about that, is that, again, their knowledge of creating test scripts, okay, and being able then to install those test scripts into a system and have them run, whether it's a digital twin or whether it's actually the BAS or BMS system, to basically run repetitive tests on a lot of repetitive equipment like terminal VAV boxes, for example, and then trend all that data to make sure and prove that everything's operating properly. You know, so the ability to write, develop, and then upload those various automated test scripts.
Okay. Our next question is, are AI tools being incorporated by any of the manufacturers of the world? And how are CX agents adapting to it?
Well, the first answer to that is yes, AI tools are being used by various manufacturers. Obviously, AI is being used in almost all industries at this point. I guess from a commissioning standpoint, I would have to know exactly what they're talking about. I went back. I talked briefly about the different ways that it can help. I think that, I guess my answer to that would be that for commissioning providers, they have to understand that that the systems that they're going to be challenged to test, to commission, which would, particularly functionally test, they're going to become more complex. They're going to become more challenging, particularly that integration between a more sophisticated monitoring-based or FDD, fault detection and diagnostic system, and a typical BAS system. And the way they're structured is going to be is going to tax them. They're going to have to be trained in how they develop and do the testing on these various systems, particularly the integration of them and how they're intended to operate. Again, the massive amount of data that's being collected from all the various sources, as I talked about, the sensors, the IoT devices, etc.
Okay, we have time for a couple more questions. One of the question is, will you be sharing a copy of your presentation slides with the audience?
I can send a copy to you.
Okay.
What I'll do is probably send a PDF file to you and let you upload or disseminate it. I don't know how many people are on the line. I'm not going to, rather than email everybody, I would rather send it to you, Billy. Yeah. Okay, I can do that. Yes, I can do that. That's the answer.
Okay, we have time for one more quick question. Is SkySpark fault detection and diagnostic system?
Yes, it is. SkySpark is by SkyFoundry, and it's a very sophisticated system. There's other systems out there. That's the one I'm most familiar with. And yes, and again, from a fault detection and diagnostics, there's the ability of these systems to not only monitor select points, but to make sure that they're within a prescribed tolerance or range, set point range. And then if they fall out of range, a lot of times they're able to make their own adjustments, to bring it back into tolerance. So that's a value of having a very sophisticated system where you've got literally thousands, if not tens of thousands of points. And for a human operator to try to monitor all these and then to react to alarms and make adjustments is just unwieldy. It's unwieldy. And that's why I talked about in the case of some of these facility managers and their staffs. I mean, if you're saddled with, I spoke recently to an individual that their campus had well over 700 buildings, okay, on one campus. So, I mean, again, it's a real challenge.
Okay, well, we'll just comment here from Sandeep Gath. UIC is doing a campus-wide implementation of AI-based energy analytics, and he's saying, please feel free to have attendee contact me at DATH, D-A-T-H, at uic.edu to discuss. So there's another source from a peer to have a conversation. With that, it looks like we have gotten through almost all of our questions, and those that we didn't, Bob will reach out to you directly. So, Bob, thank you so much for a very informative. I learned a lot about AI today, so thank you. And go ahead, Bob.
No, you're very welcome, and I appreciated the opportunity. So if anybody wants to reach out to me, my email is on the screen right now.
Okay, thank you. And I'm going to close this out with my usual saying to our attendees, thank you so much for taking time out of your very busy schedules to be with us today. So until next time, be safe, stay healthy, and let's be kind to one another. Thank you so much. Bye-bye now.